So welcome to the world of a new database, that is MongoDB. The topics that we'll be covering today are what is big data, what is NoSQL, job trends, what is MongoDB, why MongoDB, industries using MongoDB, and tools of MongoDB. Now, before we go ahead, I would like to tell you that we'll proceed in the following sequence. That first we'll see what big data is. Right, we'll understand what big data is. Then we'll see what is NoSQL and how big data is correlated to NoSQL. And finally, we'll see what MongoDB is. Now, every big data, NoSQL, and MongoDB, they all are correlated. So to understand MongoDB, you should have the basic idea of what big data and NoSQL is, right? So now let's proceed. Big data. First, the basic definition of big data. See, big data is the term for a collection of data sets so large and complex that it becomes difficult to process using on-hand database management tools or traditional data processing applications. See, or in simple term, you can say that any amount of data that is too big to be handled by one computer, that is called big data. And it cannot be managed by our regular DBM tools. The regular tools that we are having, we cannot manage this big data with that. Now, to understand big data in detail, we'll see the 4 V's of big data. These 4 V's were given by IBM. Now, these 4 V's are volume, variety, velocity, and veracity. I will explain you each V in detail so that you can understand big data clearly. See, the first V is the volume. Now, through a simple example, I will explain you the volume. See, earlier the data that was being generated in an organization was just by the employees of the organization. But nowadays, the same data is being generated by the employees, by their partners, as well as by the customers, So you can imagine what will be the volume of the data. Or another example is that most of the companies of US have at least 100 terabytes of data storage. So from this you can see what is the volume of big data that is being generated nowadays. The second V of big data is the velocity of big data. Now, the velocity is actually the speed at which the data is being created, stored, analyzed, and visualized. So that tells us the velocity of the big data. Now, the speed at which the data is created currently is almost unimaginable. So, like from the simple example that every minute we upload around 100 hours of videos on video on YouTube. So this is what the volume of this is what is the velocity of your big data. And another example is that New York Stock Exchange captures around 1 terabyte of trade information during each trading session. So this is what the speed at which the data is being generated nowadays. So this gives you the second V of big data, that is the velocity of big data. The third V of big data is the variety of big data. That is the different forms in which the big data are being generated nowadays. And there are different sources from the data is being generated, like in the form of emails, normal text, audio, videos, and there are many more forms in which the data is being generated nowadays. You can also get an idea of the variety or the different forms of big data from the simple thing that are like you can see an example of Twitter. The 400 million tweets are sent per day by about 200 million active users, like monthly active users. So this is the variety of your data that is being generated. So these are the different forms in which the data is being generated. So this gives you the third V of big data, and that is the variety of big data. The fourth V of big data is the veracity of big data. Now, veracity is actually the uncertainty in your data. I will explain you this from a simple example. That imagine you have to wish good morning to a person. Right? So wishing good morning to a person can be in different forms. You can type the complete spelling of good morning, or you can just write the short form of good morning by writing just G and M, or you can write not the complete spelling of good morning, right? But everything will signify that you are wishing good morning to the person. Now, if you want to analyze such a data, all this data, like these are different forms of data. This is the uncertainty in your data, and you have to analyze this data. So if you have to see that how many people are wishing good morning, so you have to consider all these different forms of good morning, right? So this tells you this is how the big data is having this fourth V, that is the veracity, that is uncertainty in your data, right? Any question regarding the 4 V's of big data? Any question regarding the 4 V's of big data? Anjesh, Lakshmi Narayan, Rahul, Shivashankar, any questions? Okay, so I'll proceed. Now there are, now we have seen what is big data. Now we'll see the different types of big data. Okay, Rahul have a question. Best example of velocity. See, I won't be able to give you best example, but I can give you different examples. As you can see in the last slide itself, you have another example. Like in the modern cars nowadays, you have like 100 sensors that are in your car. Okay. Now, if each sensor is like giving you data every single second, imagine how much data is being sent by 100 sensors of your cars, right? So this is the speed at which, and you can imagine the speed at which, because they're sensing the things and they're writing, like they are feeding their data up, right? So from that you can get an idea. I do not have an idea what Rahul you exactly mean by that, but the example that I'm telling you, that is one of the good example, and like this can be related to a real life, and from this you can get an idea of the velocity at which the data is being generated, right? So from this car example you can get an idea, or you can even have this idea that around 20 million of photos are viewed every day and uploaded on Flickr. Around 30,000 of photos are being uploaded on Flickr, and you can imagine the speed at which the tweets are being done, the number of queries that are being performed on Google. So from all this you can see that the velocity, the speed of the data being data generating nowadays is very high. So this gives you the velocity of your big data. Okay, Ram? Would that be okay? Okay. So now we have seen what is big data. Now there are different types of big data. There are three types, that is structured data, unstructured data, and semi-structured data. Now the structured data is actually any data that can be stored, that is, first it is organized data, and it can be stored in the form of rows and tables, right? Any data that can be stored in that form is called structured data, right? The data that resides in a fixed field within a record or file is called structured data. This include data contained in relational databases and spreadsheet. That is your structured data. See, any data that can be can be stored in the form of rows and columns. That will give you your structured data. Whereas when you talk about unstructured data refers to the data that follows a form that is less ordered than like that we have talked about in structured data, that is less of that form. That means that it cannot be stored in the form of rows and columns. That a data like that would be a unstructured data, but because it do not have any predefined structure, or it is not in an organized manner, right? So a data like that is called your unstructured data. Okay. And the third type is your semi-structured data. Now first I'll tell you what actually semi-structured data is, the first basic definition of semi-structured data. Now a semi-structured data is organized in a manner but not so organized that they can be stored in a database. See, semi-structured data do have some structure, but it is not so organized, or it is not so structured that it can be stored in the form of rows or columns. A data like that is called structured data. Or in another way you can even understand it. Suppose you have a structure of your data, and now the data in that is changing unpredictably. First of all, it is changing rapidly, and second, it is changing unpredictably. So now when the data is changing unpredictably, you cannot have a predefined structure to that, right? So a data like that would be a semi-structured data. Now I'll explain you this semi-structured data through an example that you are able to see on the screen. This is a JSON example. So I will explain you what first JSON is, because before going ahead to this example, you should have the basic idea of what JSON is. And I am telling you JSON in this example because MongoDB is actually storing the data in form of JSON. Okay, so you have to have a basic idea of what JSON is. So I'll give you a JSON. First of all, we'll see what is the basic definition of JSON. JSON is a syntax for storing and exchanging data, and it is entirely language independent. So JSON is a language independent data, and it is usually used for storing semi-structured data. It can properly store the semi-structured data. Now I'll tell you the basic constructs of JSON. The first construct of JSON is that inside JSON, the objects are wrapped inside these curly braces that you're able to see here in this example. Inside these, you will have your objects stored, and the object are represented in the form of label and value. Like this is name is a label here, and Mary is the value that is given to it. This is a label, and then this is what it is. So this is the format in which your object will be stored. Your arrays will be stored in the form of list value, like list and value. So this is your list, and these are the values to your list. And your array is stored inside these square braces. Okay, so there is a question from Lakshmi Narayan that can we say it as a key value representation? No, Lakshmi Narayan, we won't be able to say it as a key value representation because these are not keys. These are actually labels in which the data is stored, right? So these are not your key values. Even the MongoDB uses the same format of JSON. In the same way, the document inside MongoDB will look exactly similar to the document that I'm showing you here. And here the label are called field. Instead of calling them key, they called it field because these are field values. So we won't be able to call it as key value because these are not keys. These are the labels, and this is the value that is assigned to your label. Or inside, in terms of MongoDB, it will be field, and your data will be stored in the form of value. Is that okay, Lakshmi Narayan? Okay. Now we have seen that inside these the arrays are stored. Now we have seen the JSON document here. Now this side, sorry, I have represented this in an hierarchical form so that you can understand this document more clearly. Now here you have your object are wrapped inside these curly braces. So now inside this curly braces you'll have 5 labels. Your label values, your labels are mentioned here. Now your label address was having another object that was wrapped inside these curly braces. So this is your curly brace, right? And inside that you again are having some values, or you are having object inside this curly bracket. Inside your fruit label, you're having an array. You're having list values. So it is having an array, therefore it is represented by this square bracket here, and then you are having your list values here. So I have represented it in this way to make you understand what semi-structured data is. Now here you can see it is not completely unstructured. You cannot say that it do not have some structure. It do have some structure, but it is not so structured that it can be stored in the form of rows and columns. Therefore, a data like this is called semi-structured data. Okay, now so any questions regarding structured, unstructured, semi-structured data or the JSON document that I've explained till now? You can ask it. Okay, so there's a question from Shiv Shankar. That is, what is JSON? JSON is JavaScript object notation. That is what JSON is, and that it is actually it is a syntax inside which you can store your data. Okay, so through, like, it is having basic properties of JavaScript are being followed, but it is actually something in which you're wrapping your data, you're storing your data inside that. Okay, so Rahul, I have a question that can we store semi-structured data in form of rows and columns? No, Rahul, we cannot store your semi-structured data in the form of rows and columns. Okay, is that okay, Rahul? We cannot store it in the form of rows and columns. Okay, so Lakshmi Narayan's question is Pojo in Java. Sorry, Lakshmi Narayan, I do not have any idea regarding Pojo, so I will not be able to correlate it and tell you. But this is what actually JSON is. So this is, I cannot correlate it with Pojo because I do not have the knowledge of that. Okay. So now can I proceed, or any other questions? Okay, so there is a question from Shiv Shankar that do we have to have the knowledge of Java to work with JSON? No, you do not need to have the knowledge of Java to work with JSON. The JSON is actually very simple, and it do have some basic constructs, and most of them I have explained you just now on the screen. These are the basic constructs. There are some more data types that we'll be explaining you in our class so that you can understand JSON more clearly. Before starting MongoDB, we'll actually take a class of JSON to make you understand what JSON is, so that you can first understand how to work on JSON. And it is very simple that within one class you'll be perfect with JSON, and after that we'll start working with MongoDB. So there is no prior requirement or prior knowledge that you need to start MongoDB, or even to start JSON. We'll give you a class on JSON. Is that okay, Shiv Shankar? Okay. Now next is C. Now we have seen what big data is, and we have seen different types of big data. Now the data that was being generated every day from different sources was huge in amount. And now if this data is left unmanaged, the sheer volume of the data that is being generated each year within an enterprise can be costly in terms of storage. So we needed to manage this big data. Okay, so there's a question from Anjesh, that is, what is the main difference between unstructured and semi-structured data? See, the basic difference between unstructured and semi-structured data is that unstructured data is not organized at all, right? It do not have any structure, and it cannot be stored in a form, right? In an organized manner, because the data is not like that. Whereas in semi-structured data, you do have some some structure, but it is not so structured that it can be stored in the form of rows and columns, right? So you could not put such a data into the category of structure or unstructured. Therefore, it itself become a category, and it become a semi-structured data, because it was having some structure, but it was not so organized, so that you can call it a structured data. So that is the main difference between unstructured and semi-structured data. Anjish, is that okay? Anjesh? Okay, if you example of semi-structured data, see, semi-structured data, I can give you an example that the XML files in your internet, the XML files that you are having, that is actually your semi-structured data, right? So a data like that is your semi-structured data. XML files, because internet is generating data very rapidly and it is in unpredictable form. Your XML files or your semi-structured data. Whereas when you come to unstructured data can be that you are having different data together, like the data that is being generated by Facebook, by Twitter, are actually unstructured data, that they are generating unstructured data because it do not have any structure. Then you have audios, videos, and many different forms of data that is being generated, so that they are generating unstructured data, right? They're like most of their data is unstructured, right? So they are generating unstructured data, whereas your XML files through internet that you have, those are your semi-structured data. Is that okay, Anjesh? Okay, so Anjush, I have another question. So so I want to know which type of format it has. Can you please reframe your question? You are asking this question regarding what? Semi-structured, structured, unstructured? Semi-structured data, you see your XML files are semi-structured data. That is one of the biggest example of semi-structured data, and your internet is full of your semi-structured data. When as the event of your internet, the semi-structured data actually increased because your documents were not like full text documents, and therefore they were like XML files, and those XML files were actually your semi-structured data. Is that okay, Anjesh? Okay. So now we'll see what NoSQL is. Now, as I already told you that you were generating big data, and that was a problem because if an organization do not handle that big data, then it will be really costly for them, and managing this data is very important. Now, so there was a problem of handling this big data, and NoSQL came as a solution to it. Now, before we go ahead and see what NoSQL is, we'll first see how NoSQL actually came into existence. So, in the year 1970, relational database was created, and we had a standard way of storing the data and querying the data. And the data was stored in the form of rows and columns. Now, relational database could hold the data easily until the data becomes so big that now relational database could no more handle it, and the data was called big data. Now, to handle such a kind of this big data, NoSQL came into existence. The basic definition of NoSQL is that NoSQL actually is an approach to data management and data design that's useful for every large set of distributed data. NoSQL is a class of DBMS that adds some more functionality to your relational DBMS. See, NoSQL is a database are also called not only SQL databases, and actually they're an approach for your data managing your data and for your data designing, and they're mostly used by enterprises when they want to use or analyze or access their massive amount of data, that is their big data. So mostly at that time NoSQL is used. And now the term is NoSQL. It might be somewhat misleading, and you might think that it is a replacement to your SQL. But see, this is not the thing. It is rather being in replacement, it is actually a complement to your relational database management system. It is a replacement, like the things that SQL was not able to do, now NoSQL was doing them. Like the things that predefined columns and rows were holding you back, now these limits were overcome, and you now could easily store your data in this NoSQL format. So it is actually a complement, rather being a replacement to SQL. It is actually a complement to, it is complementary to, like an addition to your SQL, right? Now NoSQL are of different types. NoSQL has been categorized into 4 different types, and it have 4 different databases. and those databases are key value store database, wide column store database, graph store database, and document store database. Now since MongoDB is a document store database, so I'll be teaching you document store database in detail, but I'll give you a brief introduction about what the other three databases are. Now the key value store database is actually one of the simplest SQL database, and every single item in the database is stored as an attribute name, that is key, and together with its value. Okay, so that is how the data is stored in simple key value form. Whereas when you come to wide column store database, now wide column store database store the data in the form of columns. So everything, your data is stored in the form of columns. So when the query is run, it is run on the column itself, and from there the data is extracted. So that is what wide column store database, that is how the data is stored inside wide column store database. Whereas the third database is the graph store database. Graph store database are used to store information about networks such as like social connections. For storing a data that is network data, or the data where you want clear boundaries. In that situation, you would use graph store database. Right? Now the third type of database is your document store database. Now since MongoDB is a document store database, so I'll be explaining you document store database in detail. Now document store database is a database in which the data is stored in documents instead of rows and columns, and it is simply stored in JavaScript like JSON, as I've already told you, JSON, and the language of database that is used internally is your JavaScript. So that is how the data is stored inside the document store database. Actually what document store database is doing, that it is storing your data in the form of documents. Now document can contain many different label and values, and they can even have nested documents inside them. Okay, so Rahul wants me to explain key value once again. See, key value database, you want me to explain you key value store database? Okay, see, key value store database is actually a database in which the data is stored in the form of keys and values, that to your attributes are like keys, and then the values are assigned to them, or the values are stored with the corresponding key. So that is the most basic, the simplest of NoSQL. In simple key value, the data is stored. Okay. Okay. Now this is your document store database in which the data is stored in the form of document. Now the document based store database is excellent for keeping a lot of unrelated complex information that is highly variable in terms of structure from one another. Now if you have data that is completely like different from each other, you have complex information, you can store that easily inside your document. So that is what document store database is. Okay, Shiv Shankar wants has a question that can you give an example for each, like MongoDB for document DB? Yes, for key value store, the most popular key value store database is your Redis. Redis is your most popular key value store database, whereas wide column store database, the most popular is Cassandra. And when it comes to graph store database, the most popular is your Node.js, Neo4j.s. That is the most popular graph store database. Is that okay, Shiv Shankar? These were the examples of the other three databases. Okay. Now we have seen what is document store database, and we know that the most popular document store database is MongoDB. See, MongoDB can be used where you need dynamic queries, when you prefer using indexes, if you need good performance on your big data, MongoDB is the right choice. Even in situations when you want to do some things in like MySQL, when you wanted to do some things and predefined columns were really holding you back, believe me, MongoDB is your solution. Now MongoDB can do all those things that you were not able to do with relational database. That was your conventional database. With your conventional database, that we're not able to do. Okay. Now, see, as I've told you different NoSQL database, a question may arise that why MongoDB over them? Then why not those NoSQL database? So I'll give you the answer to this question through this graph. See, the graph here is actually given by Indeed.com. That is a job finding search engine, Indeed.com, and it provides you an indicator of MongoDB dominance through Indeed's top job trends, and a report that analyzes millions of job postings per year to identify the fastest growing skill. And actually the areas that they covered were NoSQL, mobile and social media. So this comparison is in concern with that area, with that ranges, and it was after that it was calculated that since the year 2010, MongoDB has been the #1 in NoSQL category. See, and you can ask your question, why after the year 2010? It is because the production stable version of NoSQL was released in the year 2010. That is why after the year 2010, here you can see the growth of MongoDB when compared with the other databases. You can see the growth of MongoDB. So this not only demonstrates the MongoDB's strong position in the NoSQL space, but also its technological leadership overall. Another metrics I have for you to show you the MongoDB's popularity, that is given by your Google. That was given by Google search provider, and it gave a broad indicator, and they had a comparison over the Google search volume for MongoDB over the other databases, and from the year 2009 to the year 2013, it illustrates its popularity as it was nearly 3 times as many as Google search were done at as compared to the most relevant NoSQL technology. Right, so this tells you actually the MongoDB's popularity. It tells you its strong position in the NoSQL space and its technological leadership. So I believe after knowing all this, you can have the answer to this question, that why MongoDB over the other database, because it is the most popular and it have a strong position in the NoSQL space. Okay, now we'll see what MongoDB is, what exactly MongoDB is. We'll first see the basic definition of MongoDB. MongoDB is a powerful, flexible, and scalable general-purpose database. It is an agile database that allows schema to change quickly as application evolves, and it is a NoSQL database. See, MongoDB is actually an open source database that uses document-oriented data model, and it was one of the several database types to arise in the mid-20s under the NoSQL banner. Now what MongoDB do is that instead of using tables and row as its relational database, MongoDB is built on an architecture of collection and document. Now here in this diagram, okay, so there's a question from Lakshmi Narayan, that is, what is agile database? See, agile database is actually that it do not have a fixed schema, right? So it gives you a flexibility with that it can change quickly with the application, right? So according with your application, your database can be managed, can be used with different applications, because it do not have a fixed schema, so you can use it with different applications. So this feature tells us that it is an agile database. Is that okay, Lakshmi Narayan? Okay. Now, see, here we have seen that these are the documents. The documents are stored inside collection. So this is how MongoDB actually stores the data. Inside a collection, you have different documents, and these different documents are stored inside collection. Now, if a person knows SQL, so he can correlate it and understand it more easily, that collection is somewhat similar to table and the document are somewhat similar to rows, right? So just like inside the table you are storing your data, inside your collection you are storing your documents. So this is how MongoDB store its data. Okay, any question regarding the definition of MongoDB? Any questions till now? Or I can proceed? Um, Hello, am I audible? Yeah, okay. Okay, now we'll see. I'll have a little glimpse over the history of MongoDB. See, in the year 2007, Tengen company was established and founded by Devin Merriman, Kevin P. Ryan, and Allard Horowitz, and they started working on an application platform for cloud. And it was somewhat similar to your Google App Engine, right? And they called it as Tengen's App Engine. Now, but in the year 2008, they actually realized that they needed an actual name for their Tengen App Engine, what they earlier called as Tengen's App Engine. They wanted a name for it. So they came up with the name Babel, and for the database, they came up with the name MongoDB. The word MongoDB actually comes from a word choice that is humongous. The word Mongo is from the word humongous. As in the diagram here you can see, Mongo is from the word humongous. And just a year after that, that was in the year 2009, this database was actually ripped out of the Tengen's App Engine, and the company shifted itself to an open source development model, and they started giving commercial as well as they started giving other supports. And in the year 2010, that was just a year after that, they released the production stable version of MongoDB, that was 1.4. Now the popularity of MongoDB, you can even guess from this little fact that in the year 2013, Tengen announced that it would change its name from Tengen to MongoDB, and so that they could associate themselves more closely with what ultimately become their flagship product. So now the company is no more Tengen, now it is MongoDB. Right? So this was the history. Any question regarding the history of MongoDB? Anjesh, Lakshmi Narayan, Rahul, Shiv Shankar, any questions till now? Guys, please reply so that I can proceed. Okay. Now we have the basic idea of yes, the company's name is MongoDB now. Lakshmi Narayan, yes, the company's name is MongoDB now. It is no more Tengen. Okay. Now see, we have a basic idea of MongoDB, that what is the basic definition, how the data is stored inside. Now we'll actually see why MongoDB. We'll see the different features of MongoDB, why MongoDB over the other databases, why MongoDB is so popular. So the slides that I explain you, the coming slides, they will actually tell you why MongoDB is so popular in NoSQL space. See, the first feature is its schemaless feature. See, MongoDB is actually a schemaless database, and it is one of the major features of MongoDB. Schemaless is actually that it supports dynamic schema designing and allows a document in a collection to have different fields and structure. That is what schemaless is. So this simple example I'll explain you. See, this is an employee collection. Now this employee collection is having two documents right here. Now to understand and see these two documents clearly, I have explained here document 1 and here document 2. Document 1 is having 5 fields, as you can see here: state, name, age, email ID, right, and phone number. See, you're having 5 fields in document 1, whereas when compared with document 2, you're just having 2 fields, and even these 2 fields are not having the same data types. So they're having different data types, and these 2 documents are completely different from each other, but they still are stored inside the same employee collection. So that is schemaless, that you do not have to predefine a schema, and you can enter the data as you wish. According to your convenience, you can store your data, and it will easily store. It is having this dynamic schema, so it will store your data, whatever kind of document you want to add there. Is that okay? Is the schemaless feature of MongoDB clear? Any question regarding the schemaless feature of MongoDB? Anjesh, Lakshmi Narayan, Rahul, Shivashankar, any question regarding the schemaless feature of MongoDB? Guys, please reply. Okay. Now the next feature of MongoDB is the extensive driver support. MongoDB provides extensive driver support. That is that MongoDB can extensively be used with, just a second, I think the slides are not changing. Now are you able to see the next slide? This is the extensive driver support. Okay. Okay, so there's a question from Lakshmi Narayan. Just can we take one label and we can store any type of data? Yes, Lakshmi Narayan. You can, it is not even about the label. Inside a collection, you can store any kind of document that you want, and that document can have any kind of data that you want. So because MongoDB is handling unstructured, semi-structured, and like it is handling big data, right? So it can handle any kind of data. You can store any kind of data inside your document, and that document can be stored in any collection you want. You do not have to predefine a schema to it. That is how MongoDB works. Okay. Now see this extensive driver support that MongoDB is providing. It is providing this with different languages so that you can use MongoDB easily with these languages. These languages are like some of the languages I have explained, but there are many more languages with which you can use MongoDB. Some of the languages are Java, Perl, C++, .NET, Ruby, Node.js, PHP, and there are many more languages with which you can use MongoDB. Okay, so there's a question from Rahul. That is, if we want to store more than 100 GB of data in a document, can we store that? See, you can store huge data, but there are some limitations that we have. That is, the maximum document size can be 16 MB. But now you will have a question that when we are just able to store 16 MB of data inside a document, then how are we talking about big data? Right? So the answer to this is that you can store 16 MB in normal document style, but if you want to store more data, that is a 10 GBs of data or a huge amount of data, you have to use another thing, that is gridfs, that is in file format, then you have to store that data. Okay, so basically you're storing everything in a document, but then you have to save it. If you have like large volumes of your document data that you have to store it in the form of gridfs. Okay. Now our next feature is auto sharding. Now before I make you understand what auto sharding is, I'll first tell you what sharding is. Now sharding is basically a process of splitting data up across machines. See, we can also say that partitioning of data. Sharding is the MongoDB's one of the approach to meet the demands of data growth. Now in an example right here, you can see that you are having one collection, that is collection 1, that is having different documents inside. Now when you are having just 1 or 2 documents, it was able like one system can easily handle it. But when the document increased and it could no more be handled by one system, what sharding do is that it splits your collection into 4 different locations. And what ultimately it will do is that logically it is one unit when you perform queries on this collection itself, but the data that it takes or the result that it gives you, it takes from different shards inside which your data is stored, and from that the result is being generated. So this is what sharding is providing you, that if one system is not able to handle your data, you shard it into different parts. You shard it, and but it is treated as one single logical unit, and you can perform queries on that. So that is what sharding is. And MongoDB provides you automatic sharding, that is auto sharding. See, the auto sharding feature is that you yourself do not have to worry about that how to shard this collection. You have to just give a permission that you want to shard this collection, and it will automatically shard your collection so that you can manage your data easily. So that is what is provided by MongoDB, that is auto sharding. Any question regarding auto sharding? Any questions in auto sharding? Anjesh, Lakshmi Narayan, Rahul, Shiv Shankar, any questions in auto sharding? Okay. So the next feature is replication and high availability. Now, replication, what basically means is that you keep identical copies of your data on multiple servers. That is what replication is. Now, you might think that how is replication providing you high availability? So from this simple example that you are able to see on screen, I'll explain you how it is providing you high availability. Now suppose if your data here from this server is not being replicated here. You just have this system, these two systems here. Now writes are being done here and reads are done from here. In case the server crashes, what will happen that now your data is no more available to you. Now your writes cannot be done, you cannot perform your reads. All this performance cannot be done. So now your data is no more available to you. But in the same scenario, think if you are having replication of your data. Now this was your data that was writes were done here. Now this data got replicated into these 3 replica sets. You're having your similar data available in these replica sets. What will happen in a scenario when this server will crash? You will perform your writes here. Your writes can be done here, and your reads can also be performed from the replica set right here. And even at the time when your server has crashed, at that time too you will have your data available with you. So your availability increases. You will have your data always available to you till the time your server again comes up, and then when it starts working again, the writes will start performing again from this server and reads from here. So in this scenario, you can see with replication, you'll always have your data available to you. So this is what MongoDB is providing. It is giving you replication. Your data is replicated and then it is kept, and whenever there is a crash or a scenario, then the replica sets come up and your data is always available to you. Any question regarding replication? Anjesh, Lakshmi Narayan, Rahul, Shiv Shankar, any questions regarding replication? Okay, so there's a question from Shiv Shankar. Does there have any factor for auto sharding, splitting data into how many parts? In your example, you said it in 4 parts. It is a standard, or can we change according to the machine? See, yes. See, you do not have any. You do not have any standard. You can change it accordingly. But the only limit that you have in your sharding is that before your collection reaches 256 GB, before that you have to shard your collection, because after that, if you want to shard your collection, you won't be able to shard it. So that is some of the limitations that you have before sharding. If a collection exceeds is larger than 256 GB, you won't be able to shard it. And see, as I told you that sharding is automatically, so you can have shards, right, and you can have replica sets to that, but it is done automatically, so MongoDB will itself split your data up into different chunks. Is that okay, Shiv Shankar? Have I answered your question? Uh, yes. If you have enabled auto sharding, it will take care of everything. Then it will take care, then it will, if you have enabled sharding on a collection, then it will split your data, and whenever you add your data, it is then no more your concern. You have to just add your data and it will manage your data automatically. Then it's not your concern. Then it will be completely handled by MongoDB itself. Is that okay, Shiv Shankar? Okay, so there is another question from Lakshmi Narayan, that is that is it internally creates a replication? See, no, replication can be on a standalone server or it can be on different machines, on physically separate machines. See, because actually the concept of replication is when you are doing it on separate machines. Because see, if your server crashes, you are actually replicating your data to for your high availability, that your data is always available to you. So for that reason you are doing replication. So you prefer doing it on different machines. And yes, you to your main database, that is your main, like primary I would call it, and I won't be able to explain you primary in detail because that is something deep that you have to go deep for understanding the replication. But primary server, then you'll have copies of it. You can have different copies, but you have to set this setting. You have to replicate your data, and then replication will be done automatically. Then you do not have to take care of anything. You have to just start replication once. That you have to do. That would configure it. Is that okay, Lakshmi Narayan? Have I answered your question? Okay, so there is another question. Can we manage replication a server? So this question is from Rahul. Rahul, your question is, but it is sharding automatically. Rahul, yes, it is sharding automatically, but on a collection, you have to first enable it. See, when you will enable your sharding, after that it will shard a collection, because it cannot take the decision that which collection you want to shard. Right? So you have to enable sharding on a collection, and then it will take care that you do not have to manage that collection manually. So sharding is done automatically, but first you have to enable that on, you have to tell him that, tell MongoDB that on what collection you want your sharding to be enabled. Is that okay, Rahul? Okay, so there's another question from Rahul, that can we manage replication, our server and local machine at the same time? Yes, you can manage your replication, and actually it is just configure. Once you configure your replication, then you do not need to manage it. You even do not need to take care of it, its management. It is automatically done by MongoDB. Your replication will be done automatically. Your data will be replicated automatically. So you do not have to manage it manually. You have to just configure it once. Is that okay, Rahul? Okay, so Lakshmi Narayan's one another question is that if primary server moves to another machine. See, if primary server moves to another machine, then what you have to do is, see, when at the time when you configure it, you assign your machine's IP address and all the details. So at that time, if your primary servers moves and you still want that server to be primary, at that time you can just change the configuration and you can again like reconfigure it. That is a property that is being provided by MongoDB. You can reconfigure it and you can change your primary. That is a facility that is provided by MongoDB. Is that okay, Lakshmi Narayan? Okay, so now can I proceed? Okay. Now the next is your aggregation. Aggregation is basically an operation that processes data, records and returns the computed result. Now through this example, I'll explain you how aggregation is uh, is a major feature of MongoDB and how MongoDB is using aggregation. See, in this query, you have a in this like the diagram you're able to see, there is a query that you have to find red color 1Q. Okay, before you do not have aggregation, how the query will actually work is that first it will go here, it will search for red color, it will search the red color, then it will run and find 1. The same thing will be done on the set 2 and on the set 3, and then your result will be given to you. Is that okay? So this is how it will actually work. Dataset 1, dataset 2, dataset 3, all the queries will be performed on these 3 sets, and then your data will be and then your output will be given to you. Is that okay? Are you able to see this aggregation screen, everyone? Is the screen visible to you? The screen is visible to you, right? And the marks that I have made on the screen, are that too visible? Okay. Now see, actually what happens, so this is how the queries will work. So there are 6 queries that will work to give you this result, red color 1Q. Now when you already know that most of the queries that you have, that is on your red color. So what you will do in aggregation, what you do, you made an aggregated data set. So this is your aggregated data set that most of the queries are done on red. So now how the query will work, it will not go to each and every data set. It will go directly to this red color data set, and then it will query that 1, and then it will search 1, and then it will give you an outcome. So here you can compare to 6 queries, only 1 query is being performed. So you can think that as the queries decrease, the cost decrease, the complexity decreases, and therefore through aggregation the performance is increased in MongoDB. Okay, so this is how aggregation works. Any question regarding aggregation? Any question regarding an example like this example? Okay, so now next is your document oriented storage. Now MongoDB is actually document oriented storage. This is a question from Rahul. How is query work? Like where Rahul, I can you please reframe your question because it's not clear where you want the query, like how the query is working. I have just given you an example to make you understand how aggregation actually works. This is not how the query in MongoDB works. In MongoDB, you have like your JavaScript, you have a proper syntax. According to that, the queries will. Just for example, to make you understand how aggregation work, I've explained you this like this example. Okay. Now this is your document store database. Here you have different documents. You are able to see these 3 documents. Now these 3 documents are stored inside a collection. So this is how your data is stored inside MongoDB. Your documents are stored inside your collection. Is that okay? So this is basically how the data is stored inside MongoDB. Right? Now we have seen what MongoDB, the different features of MongoDB. Now we'll see the advantages of MongoDB, that why MongoDB is preferred over other databases. The basically the three major advantages of MongoDB is that it is flexible, scalable, and it has high performance. So I'll explain you these three. See, flexibility, the basic definition, like basically what flexibility is, that you can dynamically modify the schema without downtime. You spend less time in preparing your data, whereas you spend more time in preparing, putting your data to work. See, MongoDB is doing exactly the same thing. You do not have to spend time in preparing your schemas because you do not have to predefine any schema. You have dynamic schema. You can just put your data to work. That is, you can store your data easily. You do not have to worry about how the structure should be, how the schema should be of your data. So through that, it is providing you flexibility. MongoDB is providing flexibility since it is schemaless. Okay, the second big advantage is performance. Now I'll explain you performance through these two examples, that is SQL and MongoDB. I'll compare these two databases. In this graph, what I've compared is queries per second, the time taken by queries to perform. Now there are 5,000 queries, so 2.5 seconds are taken by the query that is done by SQL, whereas 1 second is taken by MongoDB, right? So difference hardly matters. But when we compare 50,000 queries, the time taken by SQL is 27 seconds, whereas in comparison, the time taken by MongoDB is just 11 seconds. So that is how the performance is. So now the difference is very high. Now when we are talking about big data, the query is on million of documents. So from there you can have a clear idea that how the performance of MongoDB is much better as compared to any other relational database. Right, and the third advantage is scalability. As I've already explained you, through sharding, MongoDB is actually providing you scalability, and it is scaling out. That is, it is horizontally scaling your data. Horizontal scaling is that you are actually, like, you're treating this as a single logical unit, but you are splitting your entities. You are splitting your entities into, like, here you are split it into 4 parts, and logically it is treated as one unit. Now if 100 transactions are being performed, all these transactions are not performed in the same server. They are performed on 4 different servers, but it seems, because it is a single logical unit, it seems as if one system is doing all the 1,000 transactions. So this is how, through scaling out, that is through sharding, it is providing scalability to your system, to your database. Okay, any question regarding the advantages of MongoDB? Anjesh, Lakshmi Narayan, Rahul, Shiv Shankar, any question regarding scalability? Okay. Now there are different industries which are using MongoDB nowadays. Some of the industries I have mentioned, these are finance, e-commerce, gaming, healthcare, education, science. These are just some of the industries that I have mentioned. There are many more industries in which MongoDB is being used. Then you have companies that are using MongoDB, that is MetLife, Second Market, eBay, and some of the companies I have mentioned here. Okay, now to explain you I am explaining you some of the use cases of MongoDB. That is, first is MetLife. See, MetLife is actually one of the leading global providers of insurance and employee benefit program that is serving around like 90 million of their customers. What MetLife wanted was, it wanted to harness its big data by creating a 360-degree view to its customer, so it could know and talk to each and every of its customer, that is 100 million clients, individually. So now they have spent many years wanting this thing to happen, but they were unable to make a system for this. But as soon as they started using MongoDB, within just 2 weeks, they made a prototype of a new database, and that pulled together every single relevant piece of customer information, and within just 3 short months, they finished the version of this new system, and they called it MetLife, and now their customer care service is using this MetLife wall, and they're interacting to their customers So it is being used. They're using it now, and MongoDB has made this possible. And the second use case of MongoDB is the second major use case of MongoDB is eBay. See, eBay is the world's largest online auction site, and it uses MongoDB to share all the media metadata for the site. And actually, eBay is having number of projects that are running on MongoDB for search suggestion, metadata storage, and cloud management. See, MongoDB cluster is what MongoDB is doing them is that it is providing through its cluster deployment, it is providing them 99.999% of availability. So their data is like nearly 100% available to them through MongoDB. So this is what MongoDB is doing for eBay. Any question regarding the use cases of MongoDB? Anjesh, Lakshmi Narayan, Rahul, Shiv Shankar, any question regarding the use case? Okay, so now we'll see the tools. We have some of the tools I have mentioned, but there are many more tools of MongoDB. And some of the tools that I have mentioned is RoboMongo, PHP MongoAdmin, MongoDB, PyMongo, and Mongo Hadoop connector. See, RoboMongo is actually a cell-centric class platform. It is a tool that is similar to the Mongo shell. The things that we are able to do in Mongo shell, similar things we can do on RoboMongo. Whereas PHP MongoAdmin is actually used to discover the sources of connection between PHP and MongoDB. That is how this PHP MongoAdmin tool is being used. MongoDB is a tool for Java. It's a Java tool that is used to keep your Java application synchronized with MongoDB. Whereas PHP Mongo is a is a tool for Python with MongoDB, and Mongo Hadoop connector is used for setting connection between MongoDB and Hadoop. So to use MongoDB with Hadoop, we use this Mongo Hadoop connector. So these are the tools. We will be teaching you RoboMongo. Basically, what in actual deployment is preferred is that you should have the complete knowledge how to use MongoDB on the Mongo shell. But because RoboMongo is yes, and the question from Lakshmi Narayan is that are these tools open source? Yes, these tools are open source. Like RoboMongo, in the hands-on just now, I'll explain you RoboMongo. It is a open source tool. Is that okay, Lakshmi Narayan? Okay. Now, any question regarding the slides, or otherwise I'll proceed for the hands-on and I'll show you how to make how the documents and collection look like. So, any question regarding the slides, or I can proceed for the hands-on? Okay. See, now this is RoboMongo. This is how RoboMongo looks like. Here you have a new connection, right? This is the new connection. This is that you have connected to your MongoDB, that is through your new connection. When you click on new connection, you'll see the database. This is how the database is represented in MongoDB. This is the symbol for your database, and this is what represents the database. So here you have a test database. Okay. Now when you click on the test database, you'll have a collection document, a function document, and users document. Now since you're using just on one user, so you will be able to see no user. You have not made any function on your database, therefore no functions are displayed. Now here the collection, as I told you that inside the collection you have documents. So here you have a document. This is your demo document. Okay. Now when you double click on this demo document, what you will be able to see is that you'll see your different documents that are stored inside, right? Inside this collection you have different documents that are stored, and these documents are having different values. Okay. Now because this is like an interactive shell, so you can also to correlate it with your relational database for the people who are using SQL and they want to correlate MongoDB. So this is the way in which if we want to represent it in a tabular form, so this is how the data will be represented. So from this you can get an idea. A data like this can hardly be stored in a relational database. You cannot store a data like this in your relational database. So for that we are using MongoDB, right? And now this is how the shell looks like. An actual shell, when you'll work, this is how your documents will look like. This is your document. This is your document. Document 1, this is your document 2, 3, and this is how your document is being represented. Okay, so there's a question from Lakshminaran that this demo is similar to table in SQL, right? I wouldn't be saying it is similar to that, but I have just correlated the table with our documents so you can actually compare that what kind of data you are storing in MongoDB, which is completely different and cannot be stored in the form of tables. So that is what I'm telling you. For that I have just correlated the tables and the documents. Is that okay, Lakshminarayan? But it is completely different. Okay. So now you're able to see now different documents right here. So these are how the documents look like. Now RoboMongo is having some features that is like multiple shell. So I'll show you multiple shell. Now if you want to open another shell, you'll click on another collection, and then what will happen is that you'll be able to see another shell. This is your shell 1, this is your shell 2, right? So from this you can see that multiple shells can be opened, and you can open more number of shells right here so that you can work simultaneously. This is a feature that is being provided by the RoboMongo. Now the second feature that is provided by RoboMongo is multiple results. Like here we are able to see all the documents of this demo collection. Now if I want to see only one collection of the demo document, what I'll do is I'll just type find one. I'll write this command and I'll execute it. Now here you're able to see that what will happen is that you will have two results in the same shell. So like you're having multiple results. So if you want to see, if you want to compare, you'll be able to see, and you'll be able to see just one document in the another result shell. Is that okay? Are you able to see the multiple results? Okay. Are you now able to see the multiple results? So these are the multiple results. Two shells are opening. This is your first result and this is your second result. And these are the two different queries that you have just executed. Okay. Now you have another query, that is now if you want to see, it is also having this feature of auto completion. Auto completion, it will start giving you suggestion. It will itself give you some suggestion regarding the queries. Okay, so here when you click here, you'll be having a suggestion. Now what I do here is that I'll write, and I want to see that inside which the database my collection is stored. So I'll type this query and then I'll run it. So you're able to see that inside the test collection my document is stored. So this is how the auto completion works in MongoDB, in RoboMongo. Okay, so there is a question from Lakshminarayan. I'll show you one document. I'll create a document for you, but I won't be showing you how to create collection. See, because that is to do all that that is done in our first module when we'll be teaching you MongoDB. At that time we'll tell you to how to create a database, how to create a collection, and the documents and other details too. So in the demo I'll just show you a document, how to create a document inside a collection. Okay. Right, now what I'll do is now I want to create a document. So the steps to create a document is you have to go to your collection. This is your collection. In that you have to right click and you have to show enter on the insert collection option. Now this is screen will open for inserting a collection. Now I'll enter a simple collection, that is name, that is PQ, right? So I've just entered a name, and after that I have entered a number, right? And I'll enter a number. Okay, after entering your document, you have to, this validate button that you're able to see it, you have to validate it. When you'll validate, you'll see a box appearing here that JSON is valid. Okay, so when your JSON is valid, at that time if you click on save, your document will be inserted. But in case you have entered a wrong JSON document, that is, the syntax is not correct, and you click on validate button, what will happen is that you will be able to see an unable to pass JSON because your JSON is not correct, and you will be able to see an error right here. So a different colored line here. Okay, so now this is how you will, now I will put comma right here again, and then I'll see what validate. Yes, it is a valid JSON document, and after that I'll save it. Now it is saved inside. I'll open the JSON document once again. I'll go in my shell and I'll see the last document that I have entered. Yes, this is the last document that I have entered, that is PQ. It was my name, and this is the number. So this is how your document is inserted here. So this is how your document is entered here, and this is your document is inserted inside your collection. Now, any question regarding the hands-on regarding RoboMongo? Any questions? Anjesh, Lakshminarayan, Rahul. Yes, Lakshminarayan has a question that ID is auto-generated. Yes, ID is actually auto-generated. You can even define your ID, but if by chance you forgot to give an ID to your document, it will automatically give the ID to your document. So if ID is recommended in that situation when you want to have queries regarding your ID. So you want to predefine it because this is a huge, this is a big ID to be remembered, right? So because of that, you can even define it yourself, but otherwise if it is not specified, it will automatically give you an ID. You have a Shiv Shankar has a question that how can we store images in MongoDB? Yes, Shiv Shankar, we can save images in MongoDB. We can save audios and videos because we are actually talking about unstructured data. And when we talk about unstructured data, yes, we can store any kind of data. It is stored in a format which I won't be able to explain you right now because this is something that after you understand MongoDB clearly, and you understand the basics of that, and then I can tell you how to actually store your image inside. Is that okay, Shiv Shankar? Rahul, can you please reframe your question because I'm not able to understand your question. Please, can you reframe your question? Okay, Shiv Shankar, I have another question. How the image will be sharded? See, sharding, once you enter your data, sharding is completely done by your system, by MongoDB itself. You do not need to take care. You just have to shard a collection, and it will automatically see. It has a managing thing that is chunk overloading, chunk management. So if a document or a collection cannot be sharded in different shards, it will automatically manage the data so that if a data is there that is needed to be stored in one shard, it will automatically store it in one shard, and it will replace the other documents, and it will replace it to the next shards. Okay, so that is done automatically, that you do not need to take care of. You just have to enable your sharding, and everything is done by MongoDB. There. That okay, Shiv Shankar? Okay, so the question from Rahul is that if we want to retrieve a particular user data for login, how can we do? Because here is no primary key. See, here is the object ID that we are talking about, that is generated itself. That is your primary key. That is unique. It is a unique key that you are having. So if if you want to query on that, then you can obviously use this ID. That is your primary key in this. Is that okay, Rahul? Okay. Any other question regarding the slides or the hands-on? Anjesh, Lakshmi Narayan, Rahul, Shiv Shankar, any other questions? Okay, so here is what we are providing you. We are providing you lifetime LMS access, on-demand support. We'll also be providing you Easylearning.guru certification. We'll reschedule your classes on demand. We'll be having a doubt clearing session, and all the experts will be MongoDB certified experts. Okay, so there's another question from Lakshmi Narayan. Can you share the link to download MongoDB? Lakshmi Narayan, we'll be actually providing you the installation guides in our classes. So we'll teach you everything, how to download these tools in our classes. We'll be providing you proper installation guides for them so that you can install them. Okay. Okay, thank you for watching the live demo. I hope the demo gave you the basic idea of what and why MongoDB. You can always contact us on our email ID, that is contact@easylearning.guru, our Skype ID easylearning.guru, our website www.easylearning.guru. We look forward for a fruitful association with you. Thank you and have a nice evening.